Have you ever received a suspiciously timely automated email? Or maybe you had a customer service chatbot apologize to you for a delayed delivery, and you found yourself wondering, is this thing actually thinking?
Oh, yeah, it's a totally surreal moment for sure.
Right, like you're just staring at your screen, reading the words, "I'm so sorry for the inconvenience," and for a split second, you actually feel a connection.
You really do.
Well, welcome to the deep dive. Today, we're unpacking a really fascinating piece called Why the Public Still Confuses AI with Automation. We are going to find that invisible line between artificial intelligence and, simple automation.
And blurring that line might seem like just a harmless side effect of living in the future,
Right.
but confusing the two can seriously impact your trust, your financial decisions, and ultimately your rights as a consumer.
Exactly. Okay, let's unpack this because right now the term AI is being slapped on literally everything.
Yeah.
From advanced generative video models to basic automated payroll software.
Yeah, it's everywhere.
So we need to lay the groundwork fundamentally on what is actually happening behind the screen.
Well, the confusion you're pointing out makes complete sense from the user's perspective. When you are sitting at your computer or tapping on an app, the outward experience is virtually identical.
Yeah, a machine is doing a job a person used to do.
Exactly. But underneath that surface layer, the mechanical reality of how the system reaches its output is entirely different. Traditional automation operates purely as a preset, deterministic process.
Deterministic meaning.
It relies on fixed, rigid rules. A human programmer writes a script that says, if X happens, then do Y.
Okay, got it.
Think of a payment reminder sent when your account is 3 days overdue. The logic is totally hard-coded. If you give that system the exact same trigger under the exact same conditions, it will always output the exact same result. It cannot deviate from the instructions.
Right, it's highly predictable. So automation is essentially like following a strict baking recipe. If you measure out a cup of flour, a cup of sugar, and an egg, and you bake it at the exact same temperature for the exact same time, those ingredients are always going to do the exact same thing.
Exactly.
You get the same cake every single time.
That deterministic nature is what makes traditional software so incredibly reliable for logistical tasks. But when we look at artificial intelligence,
The shiny new stuff.
right, specifically the machine learning and generative models dominating the conversation today, we are operating on a completely different structural paradigm. AI is not based on fixed rules or if-then statements.
Oh, really?
No, it's based on parameters, mathematical weights, and probabilities. When an AI model is trained, it basically ingests massive amounts of data and maps the relationships between millions of variables.
Okay, so how does that work in practice, like with a chatbot?
Well, in a language model, for instance, it assigns numerical values to how often certain words appear near other words. So when you give it a prompt, it isn't searching a database for the correct pre-written answer.
Oh, wow.
It's calculating in real time the highest probability of what the next sequence of words or pixels should be to satisfy your request.
So to build on my analogy, if automation is the baker following a strict recipe, AI is more like a jazz musician improvising a solo.
I like that.
Like it knows the key it's playing in. It has mathematically mapped millions of past patterns of what notes sound good together, but the output is basically a high-speed probability calculation of what note should logically come next.
Yes.
Which means if I give the AI two very similar prompts, it might produce entirely different solos.
Yeah.
And crucially, it can hit a totally wrong note, but play it with absolute total confidence.
What's fascinating here is that this mechanical reality completely shatters the widespread public assumption that automation is just the simple version of technology. And AI is the clever or upgraded version. It is not a matter of one being smarter than the other.
Right.
It's a matter of one following undeniable instructions, while the other relies on statistical likelihood to generate an output.
Right.
And as you mentioned with the jazz analogy, because an AI model relies on probability rather than a fixed database of facts, it can generate text that is highly articulate, grammatically flawless, and, utterly convincing.
While being completely wrong.
Completely fabricated, yes. It's
Yee.
optimizing for the most probable string of words, not verifying absolute truth.
But hold on, if these two technologies are so mechanically distinct, why are you, me, and the rest of the public so deeply confused by it? A big part of what we're discussing today revolves around the fact that in the real world, the baker and the jazz musician are playing the exact same band, and the public has no idea who is playing what instrument.
Yeah, we are living in a blended digital reality. In almost every major digital service you interact with today, these two distinct technologies are layered on top of each other so seamlessly that the dividing line is just invisible.
Give me an example of that.
Consider a scenario where you're traveling and you try to buy a coffee in a foreign city. The transaction is instantly declined, and you get an SMS alert on your phone asking you to verify the purchase.
Yeah, I hate those alerts.
Right. To you, it is one single instantaneous interaction, but on the back end, you just interacted with both paradigms.
Really? How so?
An AI model constantly monitors your account, comparing your current purchase to millions of historical fraud patterns. It makes a probabilistic guess, say an 87% likelihood that this transaction is fraudulent because of the location change.
But the AI didn't actually block the card.
Precisely. The AI simply generated a probability score. A completely separate, fixed, automated business rule looks at that score.
Oh.
The human written rule says, if the AI flags a transaction with a probability higher than 85%, freeze the account and trigger the SMS alert. The fixed rule took the action based on the probabilistic guess.
So the public just sees one smooth interaction.
Yeah.
We don't see the handoff between the AI prediction and the automated business rule.
Exactly.
And I have to imagine marketing departments are absolutely thriving in this gray area because they can point to the entire process and just call it AI.
Oh, absolutely. The label powered by AI has essentially become a corporate golden ticket.
Well,
It implies to the consumer or to the investor that a product is cutting edge, adaptive, and highly sophisticated. Therefore, companies have a massive financial incentive to slap the AI label on systems that are fundamentally just standard rule-based automation.
which is wild.
Conversely, we see the opposite happening in sectors like public services or insurance. Incredibly powerful AI systems that actively dictate your access to pricing, employment, or benefits are often described in exceedingly dull operational language,
Like what?
like optimized resource allocation systems, rendering them practically invisible to the people they impact.
I want to push back on that for a second.
No.
Let's say my bank takes their standard, boring, rule-based account reminder system, the one that just automatically emails me if my balance drops below $50, and they slap a shiny, powered by AI sticker on it just for a marketing buzz.
Right.
If the email still goes out and it successfully stops me from overdrawing my account, why does it matter? The job got done. Who cares if the label is technically wrong?
Well, mislabeling the technology forces the public and regulators to ask the wrong questions when something goes wrong. Accountability requires interrogating the mechanics.
That makes sense.
If a system is standard rule-based automation, the questions you need to ask to hold it accountable are, who wrote this specific rule? Where did the trigger data come from? And who authorized this if-then process? But if a system is truly generative AI, those questions are entirely useless. For AI, you must ask, what massive data sets were used to train this model? What mathematical weights were applied to the variables? What is the model's acceptable margin of error, and how are you monitoring it for data drift?
Oh, wow. Yeah, totally different questions.
When corporations blur the labels, they effectively hide the very questions you need to ask to protect yourself.
Here's where it gets really interesting, though. If companies are mislabeling things to avoid those accountability questions, that creates a massive blind spot.
Huge.
But the confusion gets even deeper and frankly more manipulative when these probabilistic systems start talking back to us. I mean, the core of this issue hits a psychological trap when chatbots start using the word I.
Yes. We were talking about the illusion of empathy. This is currently one of the most pervasive and dangerous misunderstandings in consumer technology. The instinctive belief that an AI system possesses human-like comprehension.
So easy to fall for.
It is. When you interact with a modern customer service chatbot, it is explicitly designed to reply in a familiar conversational style. It tracks the context of your previous messages, and it routinely outputs phrases like, I understand your frustration, or I am so sorry for the delay, I am happy to fix this for you.
And as humans, we're practically hardwired to respond to that social cue. When a machine says, I understand, we naturally project empathy onto it.
Right.
We forget the mechanics we just talked about. This thing doesn't feel sorry for my delayed package. It doesn't possess an I.
Not at all.
It simply mapped my angry text prompt, ran a mathematical calculation, and determined that the sequence of words, I understand your frustration, has the highest statistical probability of being the correct conversational response. It's math masquerading as emotion.
This raises an important question, though, about the danger of that masquerade. The The danger becomes acute when users mistake structural confidence for verified knowledge.
What do you mean?
Because these language models are so incredibly polished and empathetic, they manufacture a very strong sense of unearned authority. Imagine a panicked parent typing a child's medical symptom into an AI health app, or a small business owner asking a chatbot for contract advice.
Oh, I see where this is going.
The AI will output a highly articulate, beautifully structured explanation. But it is doing so without any clinical judgment, without cross-referencing verified medical literature, and, most importantly, without any legal or moral duty of care.
It's the ultimate confidence trick. It sounds exactly like a doctor, but it has no medical license to lose if it's completely hallucinating the diagnosis.
Exactly.
And it ties perfectly into the accountability issue you brought up earlier. I've noticed a major trend where companies will deploy an algorithm that makes a highly controversial choice, and the executives just shrug and say, well, the AI decided.
Right. How language shields corporate power. The phrase "the AI decided" is a deliberate rhetorical misdirection.
Just shifting the blame.
It shifts your attention and the blame away from the human beings who hold the actual authority. Humans defined the overarching optimization goal of the system. Humans curated the training data.
Yeah?
Humans adjusted the mathematical parameters of the model, and humans ultimately signed off on deploying it into the real world. Responsibility does not magically upload itself into a server rack. Design choices are fundamentally human choices, even when they are obscured by complex software architecture.
But that illusion of empathy isn't just about us feeling good in a customer service chat. It creates a halo effect. If we think the machine understands us, we take the next, much more dangerous step. We assume its answers are perfectly objective.
Yes, exactly.
Because a computer spit out the result, people assume it must be perfectly neutral and free from human messiness.
And people consistently confuse mathematical consistency with neutrality. Computers do process calculations in a highly consistent manner, but a machine learning model is essentially a structural mirror.
A mirror.
Okay. It learns by analyzing historical data to find optimization paths. If the historical data provided to the system contains skewed outcomes, human opinions disguised as objective metrics, or historical inequities, the model does not have the moral reasoning to erase those flaws. It mathematically codifies them into its weights.
Let's ground this in a real-world scenario. How does that mathematical reflection actually play out in something like, say, fraud detection?
Imagine a bank building a fraud detection model. They feed it 10 years of past investigation reports. Now, suppose that over the last decade, human investigators disproportionately focused their audits on specific neighborhoods or specific demographics,
Right.
generating a high volume of fraud flags for those groups while ignoring other areas. The AI analyzes that data, maps the variables, and learns that those specific zip codes correlate highly with fraud.
Wow. Yeah.
When deployed, the model will consistently flag transactions from those zip codes. To a new employee looking at the screen, that flag looks perfectly neutral and mathematically sound. It's just a computer generating an alert.
Right. They trust the machine.
But the system is simply executing a flawed optimization goal based on skewed historical data.
And when you link that skewed prediction to an automated action, like freezing someone's bank account, you aren't just making an isolated mistake. You are taking a historical flaw and deploying it at scale, instantly affecting thousands of people at the speed of light.
The scale is what makes it so critical, and it applies to almost any domain. Consider a massive corporation using an algorithm to screen thousands of resumes to speed up recruitment.
Wait, so if a company uses an algorithm to read CVs and rank candidates, and they just feed it their hiring history, they might just be learning how to repeat their past biases, but doing it at lightning speed.
Precisely. They train the AI on the resumes of people they have hired over the past 20 years, instructing the model to find candidates with similar variables.
But if their past hiring managers had a habit of only selecting candidates from 3 specific universities, or subtly favoring certain backgrounds, the algorithm maps those variables.
Exactly. It assigns higher mathematical weights to those specific colleges. It's not actually finding the objectively best candidate. It's mathematically optimizing to repeat the company's past behaviors.
That's terrifying.
That is the exact mechanism of structural replication. Simply throwing more data at the problem does not fix a fundamentally flawed optimization goal. It just makes the model more efficient at replicating the flaw.
Yeah.
This dynamic leads to a psychological phenomenon called automation bias, where human reviewers, like an HR manager, accept a computer-generated score simply because it is presented with systematic authority. The algorithm ranks a resume as a 9.8 out of 10, and the human defers to the machine, assuming it possesses an objectivity they lack.
So the human in the loop just rubber stamps the AI's output.
Yes.
But then you have the complete opposite reaction in the public debate. You have people who see one highly publicized failure from an AI system, and they instantly pivot to the extreme, deciding that all algorithmic technology is an untrustworthy threat that needs to be shut down entirely.
Well, neither extreme serves us well. Rejecting all technology after one failure is just as limiting as blind automation bias.
Right.
A dynamic navigation app on your phone is brilliant at calculating real-time traffic routes across a massive grid, but it would be utterly useless at evaluating the subtle, contextual nuances of a complex insurance claim.
For sure.
Good judgment requires balanced trust. It requires knowing the specific mechanical strengths of a system and knowing when the stakes of the decision are high enough that a human must critically interrogate the output.
Which naturally transitions us to the massive underlying anxiety everyone has right now, the job-stealing boogeyman. Because if these systems are incredibly fast and management blindly trusts them, the fear is that perfectly efficient AI is going to wipe out entire professions overnight.
Historical context and current labor data suggest that technology rarely replaces entire professions outright in a single sweep. What generative AI and machine learning actually do is change the composition of tasks within a specific job.
How do you mean?
Well, a clinical radiologist might begin using an AI diagnostic tool to help spot anomalies on an MRI scan. The AI speeds up the pattern matching task, but that clinician is still structurally and legally responsible for verifying the anomaly, understanding the broader patient history, and communicating the diagnosis.
So it's less about a robot physically sitting at your desk and more about your day-to-day workflow shifting.
Exactly.
Like a data analyst might use a generative tool to produce a first draft of a 50-page report in 10 seconds, but their job shifts from writing the draft to spending hours verifying that the AI didn't hallucinate the financial metrics.
The workflow shifts, but we must acknowledge a very real insidious risk to the labor market, specifically regarding entry-level work.
Oh, yeah.
Automation and AI are exceptionally good at removing routine, repetitive, high-volume tasks. However, in many professions, those routine tasks are the exact mechanism through which junior employees learn the ropes.
Right, the apprenticeship model. Like a junior lawyer learns how to construct a complex argument by spending hundreds of hours reading and summarizing dry, repetitive case law.
If a law firm or a software company brings in AI simply to slash their junior headcount by automating all the routine drafting and coding, they fundamentally break their own training pipeline.
Wow, yeah, I didn't think about that.
They lose the proving ground for their future senior experts. Furthermore, they drastically underestimate the new, highly complex human labor required to oversee the AI, tasks like managing data security, monitoring model degradation, and handling the intricate edge cases where the probabilistic AI completely fails.
So what does this all mean? Knowing that these systems are a complex blend of hard-coded rules and probabilistic guesses, knowing that they can confidently hallucinate, and knowing they mathematically inherit historical flaws,
Yeah.
how do we actually govern them?
It's the multi-million-dollar question.
Yeah, especially when these systems are literally deciding who gets a mortgage, who gets medical care, and who gets an interview.
Meaningful governance requires demanding genuine accountability and firmly rejecting empty corporate transparency. Simply placing a vague disclaimer on a website stating, AI is used to enhance your experience, offers zero structural openness to the user.
It's basically meaningless.
Exactly. Real accountability necessitates a named owner, a specific role or individual within the organization who holds clear authority over the system and who faces tangible consequences if the system causes harm. In practical terms, a human being must remain answerable for the machine's output.
And it can't just be a one-time check, right? You can't just test an AI model in a pristine laboratory setting on launch day,
Yeah.
give it a thumbs up, and assume it's going to work perfectly in the wild forever.
No, absolutely not. The concept you are referencing is model degradation or data drift, and it is a critical component of governance.
Data drift.
A system's performance will inevitably degrade over time because the real world is entirely dynamic. Consumer behavior shifts, global economic conditions fluctuate, language and slang evolve. A predictive supply chain model that passed every safety metric in 2019 would have failed spectacularly in 2020 because global purchasing habits changed overnight. The historical data no longer matched reality.
That makes perfect sense.
Governance, therefore, has to be a full life cycle process. It is an ongoing, active monitoring of the system's alignment with reality, not just a static launch document.
So organizations really need to map this out clearly for the public. They need to structurally separate the components. Step 1. This part of the process follows a fixed automated rule. Step 2. This part uses a probabilistic AI guess. Step 3. This part involves a human caseworker who has the authority to override the AI.
If we connect this to the bigger picture, demanding that level of structural clarity completely changes how you, as a citizen, interact with digital systems.
Yeah.
The most useful question you can ask an organization is no longer, is this AI? That label has become far too muddy to be useful. The question you must start asking is, what specific mechanism is this system using to make this specific decision? We have to systematically separate what a model can technically calculate from whether it should be deployed in that context at all.
And the level of explanation we demand should scale with the stakes of the decision. I mean, if a streaming service uses a probabilistic model to recommend a sci-fi movie and it suggests a terrible one, I don't need a 50-page technical audit of their data weights. The stakes are zero.
Right. Nobody gets hurt by a bad movie recommendation.
But if a predictive algorithm automatically delays someone's unemployment benefit or denies a critical medical claim, the burden of proof is infinitely higher.
Absolutely. People navigating serious, life-altering decisions should never be forced to carry the burden of trying to reverse engineer a complex, invisible algorithmic system on their own.
Exactly.
The organization deploying the system must be required to explain its general purpose, the mechanical steps of how the result was calculated, what specific data points can be contested, and most importantly, who the specific human is that holds the power to reverse the decision.
It really all comes back to looking past the marketing smoke. Our deep dive today makes one thing incredibly clear. You have to stop getting distracted by the shiny, powered by AI labels.
Yes, please.
When you interact with a digital service, critically evaluate what this system is actually doing mechanically. Identify if it is just following a strict hard-coded rule or if it's making a high-speed probabilistic guess based on millions of data points. And above all, always look for the human in the loop who holds the real power, because responsibility does not live in the code.
Demanding that mechanical clarity, demanding to know who wrote the rules and what data trained the models, is the only viable way we can integrate useful innovation without surrendering our fundamental ability to hold power accountable.
Which brings us to a final thought I want to leave you with.
Yeah.
Something to mull over long after this deep dive ends.
Yeah.
The material we covered today makes it abundantly clear that right now, human beings are still the ones combining these strict automated rules with probabilistic AI predictions. We build the architecture and write the IF then triggers. But as machine learning models become exponentially more advanced and autonomous, what happens to our legal and moral frameworks when AI models begin writing their own automated rules without our explicit knowledge?
It's a daunting thought.
If an AI system analyzes a massive data set, mathematically discovers a new variable, and secretly authors a new automated trigger that denies people housing based on a pattern we can't even comprehend, how do we hold a human accountable when the human didn't even set the trigger? Stay insanely curious out there, and thank you for joining us on this deep dive.